Okay, welcome back. Today we're going to solve this question involved with integration by parts and a substitution methods. So this is a complex, unfamiliar question. So the question says, given the questions passing the fx's function passing through the origin, so that means f0 equal to 0. And also gradient of the function fx, which is derivative function is equal to x squared, e to the power of x times by inverse sine ex. So we need to determine what is the original function. Okay, let's solve that. So number one, we're going to start doing so let's say because the original function is the integration of the derivative function. So we substitute the expression. Okay. Now let's look at this here. We got a e to the power of x. So I can write down. So we say that's the e to the inverse sine. It's a composite function. What I'll do is I'm going to integrate this e to the power of x. We're going to push into the after the derivative sign. So that means we know derivative ex, e to the power of x is the same as ex, so unchanged. So that's the step. So look at this e to the power of x, e to the power of x. So if I say let u is e to the power of x, so therefore so these two together we can leads to, so fx actually become fu, so in relation to u, so the inverse of sine u instead of writing e to the power of x and du. So that's a lot simple. So this is the solving. So next step, I'm going to using the integration by parts because this particular inverse sine, we don't have a formula. So let's do using the integration by parts. We're going to do two parts. So first, I'm going to call, so let's revise the formula. So the integration by parts is if I have u dv is equal to uv minus v dash u dx. All right, so let's define what's u, what's v. So I'm going to call u is, so this guy is u, and that guy is, so v, so that's v. So according to the formula, will be u times by v, so be v I put in front. Sine inverse u, integration v dash, the derivative of v actually, sorry, my formula is derivative u times by v. Derivative u v. Okay, derivative u means we know this is differentiate inverse of sine u according to the formula in QCAA, which is 1 over square root of 1 minus u squared. Then times by v, which is u, dx. So don't forget this is a u dash v. Okay, sorry about that. Okay, let's do continue. So u inverse sine u. So what I'll do is I'm going to write into 1 minus u squared negative 1 over 2 into the power situation, so u dx. So let's solve this next one. So I'm going to be doing some sort of okay, now this should be easy. I'm going to integrate that one. So can you see that's a square? So I'm going to put in 1 minus u square. So I'm going to invert in. So if I'm going to integrate a u into the d, so I'm going to put 1 minus u square. So don't forget, can you see u integrate that? So you need to divide by negative half. So it becomes positive half. Because when you differentiate that, so back to u. So now you can see this is the pretty simple way to do it. So I'm going to do u inverse sine u plus half. So then 1 n plus 1, so be half times by 1 minus e to the power of u to the power of 2 become half plus c. So now easy to finish. So that's a cancel u 2 out. So therefore plus 1 minus u square plus c. All right, so now we're going to so therefore, now what's u? We're going to substitute back because we're not finishing yet. So we're going to decide what c is. So we say fx, we put it back e to the power of x. So e to the power of x is u. Sine inverse e to the power of x plus 1 minus e to the power of 2x, because that's a square. Square root plus c. Now we're going to decide what's the c, so we're going to substitute the origin into that. So that will be leads to 0 equal to, so that's become 1 sine inverse of 1 plus that 1 minus 1 becomes 0 plus c. So therefore c is negative inverse of sine 1 become negative pi over 2. So therefore my function fx solved is e to the power of x inverse of sine e to the power of x plus square root of e to the power of 2x minus pi over 2. So that's my function. Okay, this is a complex solution for integration by parts. So I'm using some techniques. So you can see what I do is move something into the D. All right, so then you can use that. Hopefully you understand the solution. If you do, please give us thumbs up. And don't forget, subscribe to the channel so you don't miss any latest video. Thanks for watching. See you next time. Bye.